So in this lecture, we're going to review the method of synthetic division. So first of all, what is the goal of synthetic division? If we have a polynomial, so a polynomial of degree n is a function of the form p of x is equal to an x to the n plus an minus 1 x to the n minus 1 plus a1x plus a naught, where an is different from 0, and all these numbers, an minus 1, and so on, are real numbers. Let's give some examples. So if we write p of x is equal to 3x to the fifth minus 5x plus 2, then this is a polynomial of the fifth degree. And you know what? Here you can see in the expression that I just wrote, you can see that all the different degrees show up. Here you will see that, for example, the fourth degree is missing, the third degree is missing, the second degree is missing. So you can always think of this polynomial as being rewritten as 3x to the fifth plus 0x to the fourth plus 0x to the third plus 0x squared minus 5x plus 2. But of course, we don't have to write all the missing terms because, for obvious reasons, that's too much and it's sort of meaningless. But the important thing is to realize that even though we don't write them, they're still there. So here's a very interesting property. So if p of a is equal to 0, then a is called a root of the polynomial p of x, and there is a unique polynomial of degree 1 less than that of p of x, say q of x, call it q of x if you will, such that p of x is equal to x minus a times q of x. So basically what I'm saying is that we can always, if we know that the polynomial has root a, we can always factor out the polynomial x minus a of degree 1. So, and the goal of synthetic division is to implement this factorization. So the goal of synthetic division is to implement this factorization. Okay, so how is synthetic division done? It's actually a good idea to explain it through examples, and maybe much easier to learn too. So take, for example, the polynomial, consider p of x is equal to x cubed plus 2x minus 3. Okay, then notice that p of 1, if you plug in 1, what do you get? You get 1 cubed plus 2 times 1 minus 3, which is exactly 0. According to what we just said, so according to the principle that we presented, we should be able to write x cubed plus 2x minus 3 is equal to x minus the root, meaning x minus 1, times some polynomial q of x. And this is some polynomial of degree. So this is a polynomial of degree 2. And the question is, how do we find this polynomial? And the answer is as follows. Write down the coefficients of the polynomial. But here's what you have to be careful about. As we noted before, some of those coefficients are missing because they're 0, and we don't need to mention them. When you write down the coefficients of the polynomial, though, you have to include the ones that are 0, meaning you have to take into consideration that x cubed plus 2x minus 3 is the same thing as 1 times x cubed plus 0 times x squared plus 2x minus 3. So you're going to have 1, 0, 2, negative 3. Okay, so these are the coefficients. And then think of this as taking place at 3 lines. So on the second line, you write slightly on the left of those coefficients the root, which is 1. And then you draw a line like this. And now you have the third line where the coefficients are going to appear. So here's what you do. Here's what you do. On your very first step, you bring down the top coefficient, which is 1. So you just write 1 right here. Okay? So far, so good. You will always do that. The coefficient of the new polynomial that you're going to make up is going to be the same as that of the original polynomial. In this case, the original polynomial had highest degree coefficient 1, and that means that q of x will also have coefficient for x squared, which is going to be its highest degree, it's going to be 1. And you can easily see why, because when you multiply x minus something times this polynomial, the highest degree coefficients need to coincide. So what do you do next? What you do next is you multiply 1 with 1, and you put it right here underneath the second coefficient. So you write the product of the two right here. So here you have multiplication. So what happened here was multiplication. And now you add them up. So you add them up. 0 plus 1 is 1. So here you have addition. And pretty much the same thing continues over and over. So you're going to multiply 1 times 1 and put it here. So that will give you 1. And then you're going to add them up. 2 plus 1 is 3. And then finally, you're going to multiply 1 times 3. And that gives you 3. And you're going to add it to negative 3. And that is going to give you 0. And the idea is that if indeed the number 1 that you had there is a root, then you should get 0. And in some sense, that becomes a fail-safe for the whole process. And the coefficients of the new polynomial are exactly the numbers 1, 1, and 3. So in other words, we can now write as finalizing what we wanted to do, x cubed plus 2x minus 3 is equal to x minus 1 times, and now I'm going to just set those numbers 1, 1, 3. So it's going to be 1 times x squared plus 1 times x plus 3x. And of course, if you want to write it in a simpler way, that's x minus 1 times x squared plus x plus 3. I'm sorry, not 3x, of course, just 3 plus 3. And that's the factorization that we were looking for. Okay. Any question that we may have here? Hopefully, we're going to answer them using by doing some more examples. Okay, so let's see if we can do some more examples. This is a rather formulaic method, and I hope that whatever questions one could have will be answered by a couple more examples that we're going to see. So here's what I would like you to do. Pause the video and try the following one. So let's do this one. We have x to the 5th minus 32. If you call this p of x, then you can notice that p of 2 is equal to 0, which means that x to the 5th minus 32 will be x minus 2 times what? Times some polynomial of the 4th degree, right? So here you will have some polynomial of the 4th degree. So I would like you to try to execute synthetic division so as to find that polynomial. Please pause the video. I'm going to give a couple of seconds so that you can have a gap. And I would like you to try to see if you can find those coefficients. Okay, let's do it together now. So first of all, we have to understand what the missing coefficients are. So it's pretty much x to the 5th plus 0 times x to the 4th. Plus 0 times x cubed plus 0 times x squared plus 0 times x minus 32, which means that we have to write the numbers 1, 0, 0, 0, 0, negative 32. And now we write the root 2 on the second row right on the left. And we bring down the number 1, right, from the top row. And then we start multiplying. So 2 times 1 is 2. And we write it right here. Okay, so I repeat, we multiply 2 times 1 and we write it here. And then we add 0 plus 2, and that gives us 2. And it's the same story. So 2 times 2 is 4, which we write right here. 0 plus 4 is going to be 4. And then 2 times 4 is 16. 2 times 4 is 8, I'm sorry, which we write here. 0 plus 8 is 8. And then 2 times 8 is 16. 0 plus 16 is 16. And finally, 2 times 16 is 32. Minus 32 plus 32, that's 0. 0 is our fail-safe, and these are our coefficients. Okay, so let's put everything together now. What are we going to get? X to the 5th minus 32 is equal to x minus 2 times x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. Okay, and that's it. Let's do one more example of a synthetic division. And let's see. So let's say that P of x is x to the third plus 2x plus 3. Notice that P of -1 is equal to 0, which means that we should be able to write x cubed plus 2x plus 3 is equal to x minus -1, meaning x plus 1 times some polynomial of the second degree. So please pause the video and try to find that polynomial of the second degree. Okay. Let's do it together now. So again, we're missing the term of the second degree. So we will have 1, 0, 2, 3. And we're going to put here the root, which is the number 1. And we will begin by bringing down the number 1 from the top. So your first move is always to bring this down. And your second move is to multiply these two and put the number right there, which gives you what? -1 times 1 is -1. So you add now 0 and -1, and that gives you -1. Now you multiply again. So now you're going to multiply these two and put the result right there. So you will have -1 times -1 is 1. 2 plus 1 is 3. And last, you multiply -1 times 3 and you put the result here. That gives you our failsafe, which is 0. So now the new coefficients are this, which means that we can deduce that x cubed plus 2x plus 3 is equal to x plus 1 times x squared minus x plus 3. And that's it. Please redo these examples if need be. And hopefully you will be able to use synthetic division from now on in order to factorize x minus a root when you know what that root is. Thanks for watching.